Hey everyone, this is Derek. In this video I'm going to cover rates of change and slope. So this is going to be looking at it as from kind of the point of view of ordered pair. And then in later videos we'll look at like average rate of change in terms of a function. So here just kind of a little reminder of some earlier algebra. Average rate of change is the same thing as slope. And that's going to be our vertical change or our horizontal change, rise over run, you might remember. And then for slope, it was when we were given the two pair, an x1, y1, and an x2, y2, we could do the change in y, so y2 minus y1 over x2 minus x1. And so given data points, this is generally a pretty convenient way to get the rate of change. So for the following chart, the following chart shows overdose deaths in the U.S. between 2010 and 2017. Calculate the average rate of change between 2014 and 2017. Okay, so I'm going to write it in this form, just so you can kind of, something you have to do is think of, so which thing is X and which thing is Y, so that you get stuff in the right order. So I'm going to come up here and I'm going to go 2014, that would go with this 47,555 people. And then in 2017, that goes with this 70,237 people. And so now you can kind of see my X coordinate is my year, my output, my dependent coordinate is the deaths. And so then to find the average rate of change, I'll do y2 minus y1, x2 minus x1. Okay, so I just wrote all that out. And then I threw that in a calculator and I got 23,182 over 3. And then since these were people, I rounded it to the nearest person, but there would generally be some sort of directions as to how to do the rounding. And so I got 7,727. Often these questions will ask you to interpret what that means. So remember right here we had deaths over year. So what this is, unfortunately, is that there was an increase of 7,727 deaths per year over these 3 years. And then in an unrelated problem, I think I grabbed this one off the homework. This one is also about drugs. So the concentration C of a particular drug in a person's bloodstream is related to the time T in hours after injection in such a way that T changes from 0 to 9 as C changes from 2.9 to 1.1. Find the average rate of change of C with respect to T. So if we're finding C with respect to T, that means T is our input variable and C is going to be our output variable. And so we look here, this is our T, and this is also T, right? So we're not going 0 to 9, it's when T is 0, the concentration is 2.9. So writing that out, at time equals 0, we're starting at 2.9. And then at T equals 9 hours, then the concentration is dropped to 1.1. So you have to be a little bit careful as you're reading which number is which thing and you know, get stuff labeled. So for me, it really helps if I identify my ordered pair that I'm putting in T's, I'm getting out C's. These are both T's, so that has to be a T1 and a T2. So this has to be a C1. These are both concentrations. So this is a C1 and a C2. So anyhow, once you get stuff identified right, then it's great. You just toss it in the slope formula. So this will be 1.1 minus 2.9, 1.1 minus 2.9 over 9 minus 0. And then that comes out, if you throw that in a calculator, to negative 0.2. And if I were being particular slopes with, units on this, it would be milligrams per cc per hour. So it would be decreasing this many milligrams per cc per hour, every hour.